Welcome, this is EGME 331 Solid Mechanics. The topic for this video is Elastic Modulus or Young's Modulus. Before we talk about Elastic Modulus, let's take a brief look at stress-strain diagram. For most engineering purposes, we use stress-strain diagram as a means to understand the material behavior and properties. And these properties includes elastic modulus, yield strength, ultimate tensile strength, and so on. Here you can see a stress-strain diagram of two different metal alloys. One is a aluminum alloy and the other one is low carbon steel. The vertical axis, the y-axis, shows the stress and the horizontal axis shows the strain. You could see multiple critical points marked from 1 to 6 on this curve. The first one indicates the elastic behavior, and that's where the elastic modulus comes into picture. Let's define proportional limit. So proportional limit is a stress at which the stress strain plot is no longer linear, which means it starts to take a curve. And what is important here is the strain at this point, at the point of proportionality, is only representing a very small portion of the total strain the body would undergo before it fractures. Here in this figure, you could see the proportional limit at 43.5 ksi stress, and the line, the stress strain plot tends to curve and move away from the linear behavior. The corresponding strain here is 0.004 inches per inches. So what's elasticity? Elasticity is the behavior of the material to return to its original shape or dimension after the load is removed. The material within the elastic region does undergo deformation. However, once the load is removed, it doesn't show any evidence of permanent damage. And that's the importance of elasticity. Beyond the elastic limit, the material tends to accumulate some amount of permanent damage. So coming to elastic modulus, this is simply a term that is used to define the behavior of the material within the elastic zone. So elastic modulus, which is also termed as Young's modulus because of the person who proposed this term, Thomas Young, in 1807. So elastic modulus is the ratio of the stress and strain within the elastic limit. So the elastic modulus or modulus of elasticity is denoted by the letter E, which is the ratio of change in stress over change in strain within the elastic limit. What does the elastic modulus represent? So we have learned about strength, and now we are talking about strength is the highest stress the material could withstand when it is subject to an external load. After that highest point, the material tends to fail. In contrast to strength, elastic modulus is a representation of the stiffness of the material. Now, stiffness is, unlike the failure of a material, stiffness represents the deformation. So in terms of stretching or bending, or depending on what kind of load is applied. So stiffness is the ability of the body to retain its shape, attempting to retain its shape. And that's what elastic modulus represents. The unit of elastic modulus or Young's modulus is same as the unit of stress, which is because the ratio of stress versus strain, and strain is dimensionless, so that leaves us with the unit of stress. So you can denote elastic modulus in pascals or most commonly in megapascals or pounds per square inch, PSI.